All right. Well, here we go. We're going to go through a bunch of tutorials on how to solve various things involving conic sections. The top two are going to be parabolas and ellipses. We're going to start off by going through some problems that I had on a quest in my class, and just to make sure that everybody knows how to do them. So we have our problem number 2. We are talking about parabolas. Okay, parabolas are coming from a conic section. We're going to divide it, all right, in half, and it goes through the base. So you take your plane of your cone and divide this through, and when you divide this through, okay, what happens is it creates a parabola. Okay, it creates a parabola inside this cone. All right, because you got this right here, and then it's going to come down right there, and you create the parabola. Now, since we have this parabola, there are some key things you want to remember, all right, how to do this, because what we have is our basic equation of a parabola. Now, we learned about this in Chapter 1, a lot of these different things. However, in order to find the focus and directrix and the vertex of a parabola in standard form and a conic standard form, one of the key things is we want to make sure that the square is on one side of the equal sign and the coefficient next to the constant is on the other side. That is one of the key things. So make sure you put it in correct form. All right, correct form. All right, correct form. A lot of students forget that. So before we do anything, we're going to go and take x minus 2, we're going to square it, and we're going to add 16 times y plus 5 to this other side. Okay, from here now, what we're going to do is we're going to find our vertex. Now, our vertex can be found right here with h and k, and so we have right here is 2, negative 5, 2, negative 5, all right? And now we're going to find our foci, our focus, and our directrix. Now, in order to do this, we are going to take our parabola, which you have 1, 2, 3, 4, 5, right there, negative 5. And now this parabola is going to be opening up, okay? Opening up because we notice our coefficient is positive. So we're going to open it up like so. Now, you have to make sure that you put this on the other side, because if you look up here, you see it's negative. Unless you put it into the correct form first, you'll get a bad knowledge of what this parabola is doing. So, once we have it in correct form, we identify this, and now we realize that our focus is going to be also going up. So in order to find our focus, we're going to be adding values to our y value. So in this case, right here, our 2 is going to be the same. Now to find our focus and our directrix, we need to know the p-value. Now the p-value is when we have, in this form, standard form, the coefficient next to the non-squared expression, non-squared, so this is the non-squared expression, all right? That coefficient equals 4p, all right, 4 times p. P is the distance from the vertex to directrix and the distance from the focus, okay? It tells you the location. So as we have this, in order to solve for p, we're going to take our, all right, coefficient, 16, we're going to set equal to 4p, divide by 4, we get p equaling 4. Okay, what does that mean? That means our focus is going to be 1, 2, 3, 4, 4 units higher, all right, there. So we're going to add 4 to negative 5, so negative 5 plus 4. All right, and our p-value, and we have our new focus value, that's going to equal 2, negative 1. 2, negative 1 is going to be our focus. Now the directrix is going to be 4 units below that. So we're going to go 1, 2, 3, 4. Now this is a line. In this case, it's a horizontal line. All right, and it's going to be 4 units below. So this is going to be an equation of y equals, in this case, we're going to take our y, subtract 4. So take from our vertex, negative 5, minus 4, which is our p-value. You notice that. So we have y equals negative 9. All right, y equals negative 9. Now from here, why do we have this stuff? Well, because, if I drew this correctly, distance from here to distance from here, and obviously this is not a good scale, it's not very well drawn, all right? But right here, these distances should be the same. So this is not a very well drawn parabola, because those distances should be the same, all right, for this conic section. All right, well, let's try another one. We're going to do the same thing, but now we have this. So once again, similar problem, all right? These are on test A or B, okay? So what we're going to do is, once again, same thing. First thing, put it in correct form. So make sure your square is on the one side and your non-squared term with the coefficient is on the other, because you always need a 1 right here, which we have. So we have 12y plus 5. Now from here, we can find our vertex. We have 2, negative 5. Now we have to find our focus and directrix. Okay? Find the focus of directrix. Once again, we have to find the p-value. So p-value comes from there. So 4p equals 12. P has to equal 3. Okay? So once again, if you want to draw this, you can see that it's going to be going up because x is squared. All right, it's a normal parabola. So 1, 2, 1, 2, 3, 4, 5. Right there. That. And we're going to go 3 values up. So we're going to add -5, and we're going to add 3. So what we have then is 2, -2. And go 1, 2, 3. And that makes sense. Another focus. And then finally, our directrix is going to be 3 units down from the vertex. 1, 2, 3. And once again, this is going to be a horizontal line because it's going vertical. So we have y equals, what is that going to be? Well, to find that, we go y, take the y of our vertex, -5, and now we're going to subtract the 3 value because it's going down. And we have y equals -8. And there you have it. So, as you do this, the focus is always inside, once again, reviewing. The focus in each one of the parabolas is always inside of the parabola. It's inside the parabola, so if you're wondering where is it going, it's always inside of the parabola. It's opening up if you see the coefficient next to the non-square term is positive. It's going to be opening up if x is squared. It will open sideways if y was squared. Okay, and it always opens to the right. It opens to the right if y would be squared, and it would just be next to x. Unless there's a negative, then it opens to the left. But these are essentially the key things. The directrix is always outside of the parabola, and is in the equation of a line. Let me finish this up. -8. And there you have it. Well, I hope that helps you out with number 2. Very detailed. Maybe you need some help with this, maybe not, but good luck and help us on the rest of your problems.